Hello everyone, in this tutorial I'm going to teach you how to make a 2D axisymmetric geometry in a blockMesh of OpenFOAM. As you know, there are other several ways to do the 2D axisymmetric by making the geometry in SolidWorks or other CAD software and then import that CAD file to the Fluent or other machine software. Then after that we import it to the also to the OpenFOAM. But in this tutorial I'm going to make all these processes only in OpenFOAM and with the blockMesh of the OpenFOAM. Before going to the OpenFOAM platform, I will just make some paintings for you and you will understand that how it's working. For the cylinder, in this tutorial we are going to simulate a horizontal cylinder. If you consider like cylinder like this, for a 2D axisymmetric, we select a very small part of the whole cylinder and then we rotate it in the axis, one of the axes. So it doesn't matter which axis we choose. If this is our cylinder, 2D axisymmetric cylinder. Okay. So the reason that we do the 2D axisymmetry is that we don't want to simulate the whole 3D cylinder because it is computationally it's so expensive and all the if we just simulate in part of the cylinder we can say that it is the same for the whole cylinder, so we don't waste our time and energy to simulate the whole cylinder. That's the point of doing the 2D axisymmetry. So this is our cylinder, and I will name these parts. This point 0, this is 1, this is 2. You know, we have to number all the points that we write. This is 3, and this is 4. We'll use these points in the OpenFOAM. And this is 5. So we need only 6 points to do to make our 2D axisymmetric. But if sometimes you need more, if you have other parts, I mean, if you have CHD simulation, if you have some solids above this, okay, of course you will need extra points. But for the basic cylinder, 6 points are enough. And for this tutorial, I will just write. If you consider the radius of, I did it for one of my papers, so I will write the same. Okay, the radius could be 0.5 meters. Then we can have the height could be like 0.023 meters. And one thing that we have to calculate is this part. Use the red one. This part. We should calculate how small should it be. So we will use only one mesh in this part. So we should make it a bit small. So it will be a good approximate. So how to calculate this? If we consider this is our x-axis and this is y and this is our z-axis. So these are in the z-axis now. And how to calculate the z? Z equals r theta or times the angle in radian, and the angle that we mostly consider is equal to almost 2 degrees. Okay, and so how to calculate the angle? Angle is equal to 2 degrees, and we have to calculate the radian, which will be about, like, if I'm not mistaken, 2 degrees is like 0.0349. And at the end the z will be like, if we do the calculations here, so I'm doing step by step, we don't miss any part. This will be time t, so it is almost 0.005 meters in z direction, this and this. So this is on the z direction, but if we want to, I will use half of it, like z0 is here in the middle, so we will divide it to the 2 to have this if our z0 is here. Okay, with this information we can go to the OpenFOAM and solve and create our geometry. We go to tutorials, like always we start from 0. I will take the cavity, which is the simplest case study to do. I will paste it here. I'm using OpenFOAM 13, so it doesn't matter which version are you using. This is the same procedure. I will go to the system, then blockMesh. This should be 1. Then I will delete 2 of them because we needed 6 points, as they told you. 0. The first one was in 0, 0. Then the first 3 points were in x equal to 0. And the radius in y direction, and z. Well, either you can use 0, then the next z should be 0.0005, but I just think that I use it mostly, so it doesn't matter which method you use. And the second one, third one will be the same, but it's a positive z. And I don't remember exactly the height, but if I'm not mistaken, it was 0.02616. Y was 0, and x is minus, z is minus 0.0025. So the same. Y. So yeah, sorry, this should be 0. Then this has to be minus, yeah. That's it. So we save it here, Control S. Then blocks. How we make the blocks? If you go to the this painting, the blocks should be these, the surfaces that is going to rotate around the x-axis. So it will be 0, 1, 4, 3, and 0, 2, 5, 5, 3. So this is the block. If you use 3, 4, 5, 3, and 1, 0, 2, 1, it's not going to work because we are going to rotate this very small pi on the x-axis, and these surfaces are going to rotate. So if you go to the OpenFOAM blockMesh we had, and the blocks that we need are 0, 3, 4, 1. Just when I'm writing these blocks and doing some simulations, just remember, just take a picture from the painting that I draw for you. Then after that, you can understand why I'm using these faces. 0, 3, 5, 2. In the Z direction, we use only one mesh, and it could be, doesn't matter. Just 18, the same, I don't know, 16, something like this. We are not going to run it, we are just making the geometry. And for the boundaries, the cavity was a 2D geometry, but we are going to use in 2D axisymmetric, and front and back could be deleted, or just make to run type. We use for this is the most important part for the boundaries, for the surfaces that are going to rotate. We use the wedge type. You write wedge for the front. Okay, what was the front face? It was 0, 1, 4, 3. I'm writing this with the painting that I have in front of me. So if I want to show you again, this is the face, the back face, the back surface. Then after that, I will write this for the front, back. Okay, so we will use the same for the back. Same, but the same type, and the back will be 0, 3, 5, 2. That's it. Then we need to make boundary for other faces as well. The moving ball could be like one of the faces. We can put all other boundaries in one type, but I don't want to make a new boundary condition. Just I want to use the same thing, the same names, because when I want to edit the 0 folder, then in that case I have to change all the names. So that's why I'm using just one boundary condition, the same boundary conditions name. The moving ball we could write for 3, 4, 5, 3. I mean, this one 3.53, then we can write 0, 1, 2, 1, then this 1, 2, 5, 4. This is the moving wall. Because I don't want to make a new one, I can also write one of the faces here, which is 0, 2, 1, 0. The fixed wall on the top of the cylinder, the surface will be something like it could be 1, 2, 5, 4. I mean, this surface, ball surface here. Okay. Then let's go to the OpenFOAM. Then we can save it. Go to the folder, IT, and write blockMesh. Okay. Good. So we don't have any errors. Perform. Open. Apply. We don't have boundary conditions. This is, and as you can see, this is our 2D axisymmetric geometry. We have to work with the meshes to make it more convenient. At this point, the meshing is not very good. You see some problems here. So that was how to make a 2D axisymmetric geometry with the OpenFOAM blockMesh. In the next tutorial, I'm going to teach you how to make a full 3D cylinder with the blockMesh of the OpenFOAM, so you don't have to import it from the other CAD softwares like SolidWorks or etc. So I hope this video was helpful for you. If it was helpful for you, just please like the video and share it with your friends, and don't forget to subscribe to the channel. See you next video.